Hey guys, what is happening? Today we're going to jump back into our Java OpenGL 2D game development tutorial series. First, I want to wish everyone a happy Hanukkah or Merry Christmas, or whatever holiday you happen to be celebrating this time of year. And I also want to mention that I'm trying to put out videos every Monday through Friday. So subscribe so you don't miss any. I know I missed putting one up yesterday. I was kind of busy. It was my brother's birthday. But we're going to try to put up a video every weekday. So subscribe so you don't miss them. Now that said, we're going to be creating a method today for drawing images to the screen. It's going to be like our fill rect method, except that instead of filling it with a solid color, it fills it with an image. And this is obviously going to be important whenever you make games. So you're going to use this method over and over and over again. So the first thing I want to mention is that I'm going to be jumping back and forth between our project here and some code that I wrote previously. That's going to be over here. You don't need to do anything with this. I'm just going to be going back there to remind me of what we're going to be doing in here, so I can remember how I did it. That was some code I wrote for a 2D game engine a few months ago. And so the first thing that we're going to do is we're going to need an image to draw to the screen so that we know our code is working. So you're going to need to create a new package. I've already done this, and I call it res, R-E-S. And it's basically going to be resources. All of the resources, music and sound and images for our game are going to go in this resources folder. Inside of it, I have an image that I pulled off the internet. You can use any image you want. It's just a 256 by 256 image of Nicolas Cage's face. And so that's what we're going to be drawing to the screen today. And you can use any image. It doesn't have to be 256 pixels by 256 pixels. It doesn't have to be Nicolas Cage's face. So, what we're going to do, we're going to create a duplicate of our fill rect method. We're just going to copy and paste to create a new method. And we're going to change that to draw image. And basically it's going to do the same thing, except it's going to map a texture to the quad that we draw. And so we need it to take an image resource. Image resource. Resource, make sure you spell it right. And we'll call it image. That's the first parameter it's going to take. Now, if you try and import, you're not going to get anything. If you do get something, it's not what you want, because image resource is a class that I made up that we're going to be using for our game. And so we're going to create a new package. I'm just going to call it org.resource. And this is going to be where we're going to hold resource classes. And it'll make more sense later. Basically, you don't want to be using, whenever you're using a game engine, you often want to have some sort of resource management system that handles the loading and unloading of resources and things like that. Don't be too distracted by that. Just know that we're going to create a image resource class that is going to be our image resource, and it's going to be in the org.resource package. So go ahead and create that new class. And what we have, if we save that and we go back into graphics, we can import image resource now, and that should fix the error. Now, image resource is going to contain, basically, in OpenGL, at least this kind of OpenGL that we're using, you have to bind a texture object to your OpenGL context in order to draw it to the screen, or draw it onto whatever object you are, whatever quad or triangle or whatever it is that you're drawing. And so the way we're going to do that is we're going to load the image using this image resource. And now we're going to go real quick and take a look at how I did it previously, because I need to refresh my memory. Okay. The first thing is it's going to need a private texture, and just call it texture, and initialize it to null to begin with. And if you import, you'll get a couple of options here. The one we want is not javax.media.j3d.texture. We want com.jogamp.opengl.util.texture.texture, because that's the one for OpenGL. Okay. We're also going to want a private buffered image. We'll just call this image, and it is equal to null. And import that. And I'm just going to comment this real quick. buffered image of this image, the OpenGL texture object. I just like to comment my code that way. I also think it makes it look nicer. So I'm going to check my code again real quick, make sure I'm doing this right. Okay. Construct an image from a path. That's what we want. Basically, we're going to create a method, or it's a constructor really. Public image resource, and it takes as a parameter a string. This is the path to the image. So string path, the path to the image file that we want. And the way we're going to do this is, now notice that this path, the way we're going to load it, is going to be like this. It's going to be URL equals image resource dot class, I think, dot get resource, and we're going to give it path. And what this is going to do, this means that our path is going to be relative to our Java project, depending on how we do this. We're going to have to import java.net.url so that we actually get this URL right here. And next we're going to use image.io, if I remember right. Image.io, yes. So what we're going to do is we're going to say the image equals image.io.read, and we're going to pass it the URL. And you'll get an exception that we're going to have to surround with try catch, like that. So the next thing that we're going to do, so basically, just to make sure you understand what this does, it gets the URL of a resource that is in here, and this resource comes from the path name that we pass to it. And so since we're using imageResource.class.getResource to return the URL, this is going to be relative to, I think it's our image resource class, unless we put a slash in front of it. In other words, if we say to get the image called, face.png, or something like that, or in this case it's image.png, which is Nicolas Cage's face. If we say get the resource image.png, it'll only get that image if this image file is in the same package as the image resource class, I think. It'll make sense later. We'll explain a bit more about how we're going to construct the path to be relative to certain things after we get the image loading method done. So then what happens is we take the URL and we use image.io to get a buffered image from it. The next step is going to be to turn the buffered image into an OpenGL texture object. And the way we do that is, actually, it looks like in my code, what we ended up doing, yeah, I see what we're doing. Okay, so the first thing after this, if image does not equal null, then image.flush. If I remember right, I had to do this because otherwise there was some kind of memory leak. I don't remember how it happened, and I don't remember what it was all about, but if I didn't put this in the code, I don't fully understand it myself. If I didn't put this in the code, I ended up using way more memory than I should have been using. I don't know why that was, but I'm just going to say that's why I do that. Alright, and then we're going to need a method that lets us get the texture, and the reason why I don't get the texture automatically is because it'll take more memory if we get the texture and then never use the image. We got the texture for no reason, and that's unused memory for no reason. So we want to only get the texture like this. When public texture, get texture. And now, basically what needs to happen is, if texture is equal to null, we need to turn the image into a texture object and put it here. If texture is not null, then we've already gotten the texture object and can just go ahead and return it. So I'm going to put a little comment sign right there so we can go back to this. And basically at the end you're going to say return texture. So if texture is null, we get the texture from the buffered image. If it's not null, we'll just move on to returning the texture. Either way, we're going to end up returning the texture when we're done. And so in my old code, what did I do? Oh yeah, another thing we want to put in for get texture, if image is equal to null, then return null, because there is no image to turn into a texture. And this could happen if you made a mistake when you were loading your image. It shouldn't happen otherwise. All right. Section equal null. Okay, I'm gonna copy this line real quick, and then I'm gonna paste it in and explain to you what we're doing. Basically, we're gonna say texture equals aught texture IO. That's capital AWT, capital T, texture, capital IO. And that is something you're going to have to import. Actually, we'll import that in a second. Basically, that dot new texture, and it's going to take three parameters. It's going to take the OpenGL profile that we're using for our rendering. It's going to take the image that it's going to turn into a texture, and this last parameter, just set it for true. You don't need to know anything about that one for now. For our purposes, just set it to true. Now, a couple of errors I gotta fix here. This renderer is not going to be renderer, but it should be. Is it going to be graphics, or is it going to be something else? No, it's not graphics. No, it might be renderer. Did we put a getProfile method in renderer? Let me double check. I'm going to import renderer, org.graphics.renderer, and yeah, getProfile is not a thing there. Also, aught texture IO should import whenever you use the import command. Gonna go to the renderer class now. And yep, right here I made this a local variable. I should have made it public. So in our renderer class, we're gonna change glprofile equals glprofile.get glprofile.gl2. Change that by getting rid of the GL profile at the beginning and creating it up here. We're going to say, let me create it near a window. It's going to be private static GL profile equals null to start. And then we got to create that method to get it. And that should be simple. Public static GL profile get profile return profile. That's all it needs to do. And so that's going to help us get our GL profile that we used. And the image resource class needs to know this in order to create a texture that is compatible with the GL profile we used. So once again, if texture is equal to null, then texture equals aught texture IO dot new texture. And it takes renderer.getProfile, it takes the image, and it takes a boolean. In this case, we're just going to say true. Okay, so that should be all that is needed to get the image resource. And so to test this out, first off, we're going to need to make our drawImage method draw an image from this image resource. And so I'm going to go back to remind myself how I did that in my old graphics class. A lot of stuff in here, as you can see. We're looking for the drawImage method. Here we go. Okay, blah blah blah, cameras, optimization, doesn't matter here. Alright. So what we're going to do, drawImage, we're going to need to get the texture of the object. And we're going to do that by saying, okay, I'm going to double check to make sure I know what I'm doing. Yeah, okay. So texture, text, we're just going to call it text for now, equals image.getTexture. Okay, and we're going to import OpenGL texture, like so. And then we're going to need to bind the texture, and we do that by saying if text does not equal null, because we can't bind a null texture for obvious reasons, that just doesn't make sense. And what we need to do is use this function here, gl.glbindTexture, and it takes this constant from the GL2 class, and it takes the texture object. And so we're going to say gl.glbindTexture. The first one is going to be gl2.glTexture2D, I think. Make sure that's the one we want. glTexture2D, that's correct. And then it takes text.getTextureObject. And that will return us the texture object. And it binds the texture to our current OpenGL context. So if we refer to any texture in the GL context from now on until we unbind the texture or bind a new texture, it's going to refer to this texture right here. And so that's how we draw images, is we map them to two-dimensional, like quads and triangles and things like that. Alright, set the proper filter for scaling. For now, that won't be necessary, I don't think. We'll add it after we get the image up and running, because I just want to get that started. Okay, so this right here is basically, this is the main thing that we're going to do that's going to make this different from drawing a regular rectangle, is that we're going to map GL texture coordinates to the things that we do. Well, okay, first off, I just noticed here it says gl.gl flush at the end of drawing. I'm going to add that in real quick. gl.gl flush. And at the end of fill rect also. Looks like I forgot about that whenever I made that method. Okay, so before we draw each one of these vertices, we want to add texture coordinates. So that's why I'm just gonna make some room right there for our texture coordinate lines. So this first one, that is going to be gl.gl text coord 2f, as in it takes two floats, 0 and 0. Now texture coordinates are normalized. This means that 0 is the far left on the x, I think, and the bottom on the y-axis, and then 1 is full all the way to the right, and 1 for the y-axis is all the way to the top. So all your coordinates are going to be in a range from 0 to 1, and that's why they need to be floats, so you can use decimal precision. Now, above the next one, gl.gl text coord 2f, and it's going to take 1 and 0. Now, oftentimes what ends up happening, this is part of why I'm using this code I wrote previously, what'll end up happening is I'll draw this and the image will be backwards or inverted upside down or something like that, or rotated because I don't know what I'm doing as far as the texture coordinates go. This one's going to be 1, 1. And then again, gl.gl text coord 2f. And this one is going to be 0, 1. And so, if we save that, we can't test it yet, because we don't have an image resource. Oh, also after we've finished flushing the GL, we're going to need to do gl.gl bind texture gl2.gl texture 2D, and this time we're going to say 0, which means bind nothing. So we're not binding any texture at all. Okay, and so what's going to happen here is we're going to need to create an image that we can draw. So in the event listener class, where we did fill rect, let's real quick, we're going to say graphics.draw image. We're going to pass it image 0, 0, 100, 100. Okay, and image obviously will get an error there. So what we're going to do is here I'm going to say public static image resource image equals null, import image resource, and then in the init method we're going to load the image. And the reason why we have to load it in our OpenGL, if I remember right, we have to load it in our OpenGL methods. I might be completely wrong about that, so ignore what I just said just in case. So right here we're going to say image equals image resource. It's going to be a new image resource, and it's going to take a path which we're going to say is /res/image.png. Now hopefully that loads the image properly. We'll find out soon enough. I'm going to go ahead and press play. Please don't crash. And we get a big white screen. That could mean we got an error. Let's find out. I'm going to quit the program, and we did get an error, yes. At least that tells us something. Exception in thread, blah, 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 and reader based on comments. Or maybe we didn't. What's that all about? Because I don't think the error that we got has anything to do with that. Let's test this again. After we load the image, I'm going to say system.out.println image, just to see if the image actually is something. We're going to run it again. And we get this. So quit that. Org.resource, image resource. So it is a new thing. What about image.getTexture? Is it a thing or is it null? Let's find out. Do that. And quit. No, it says it's a texture. It says it's 256 by 256. It has loaded something. Okay, what am I doing wrong here? Why are we getting a big white screen? Where did I make a mistake here? Let's go to graphics. I like to include these parts in the tutorials where I don't quite know what I did wrong, because even if you know what you're doing, you'll make mistakes sometimes, and I think it's important to watch someone, to learn what actually happens when you make a mistake and how you can go about solving it. So we know that we've gotten the texture, but we don't know that it's being drawn properly. So let's okay, here's one thing. Go into the event listener class, comment out the draw image line, and see what happens. Okay, when it's commented out, we get a black screen, not a white screen. So that means it's got something to do with that. So let's say draw image again. And I'm going to go graphics, where we do the draw image method. Yep, pass it those things, and it draws the image. Okay, so let's run it, and we get the white screen. Why do we get a white screen? That's the question. Exceptions for OpenGL exception. See, this exception that we're getting here, I think, has to do with the fact that we're not properly shutting down the OpenGL context, which we will get to that later on. I just wanted to do some of the more interesting stuff first. That's why we're doing image rendering here. Oh, okay, wait, I think I might know what we did wrong, possibly. We need to enable the rendering of textures in our OpenGL context. So in the init method right here, we're going to need to say gl.gl enable gl2, I spelled that wrong, gl2, capital GL, .gl texture 2D, I think that's what it is. I think that's how you enable textures. Let's run it again. Okay, we're getting something different now. We're definitely getting something different. Oh, okay. I did something stupid. When we were drawing the image, I said width and height are 100 by 100. That is assuming we're using pixels, which, as you know, we're not using pixels anymore. I can't believe I made that mistake. Remember, we changed it to units in a previous video. Set that to 1 and 1. That's why the image was so big. And that's why it filled the screen with a solid white color, because since textures were not enabled, all we were drawing was a white rectangle. For example, if I comment out that line, gl.gl enabled gl2.gl texture 2D, we should get a small white square. Now that I've changed this to 1 and 1, we'll get a small white square on the screen. That used to be a large white square on the screen. Well, I guess it's a diamond, because we rotated. Where do we do the rotating? Oh, okay. Back in the graphics class, change rotation back to 0. We want it to be 0 by default. Now it should be a white square. And this filled the screen before. That's why we were getting a large white square, or a large white screen. And then whenever I enabled textures, it turned to a large skin color screen, because it was basically Nicolas Cage's face scaled up really large. Scary. So, go back to the event listener, and uncomment that line gl.glenable gl2.gltexture2d in the init method. And when we run the code, now see what I mean about the image, the textures. The image is upside down. We don't want it to be upside down for obvious reasons. Okay, let's see if I can remember the right way to do this. Real quick, we'll see if we can kill two birds with one stone here. In your graphics.drawImage, I'm going to change this to 1. This should be the y coordinate. Does the image go up or down? Okay, it goes up. In that case, we'll just change the order of the coordinates for the texture. So go back to the graphics class. I realize this is probably this episode is probably difficult to follow, or takes too long and just goes all over the place. So I hope it's not too difficult to keep up, because it's not very organized, since I had to go back and look at some code I wrote previously. So we're going to change the way that we're doing this. Now if we look at our original image and we rotate it so that it's upside down, you can see that I think what we're getting is not a rotated version, but rather a mirror image, something that's been mirrored on the y-axis. Oh, what? Okay, what just... Oh. Okay. I forgot that on this version of Mac OS, it saves modifications that you make like that. So it automatically saved the rotation. No, that shouldn't have happened on yours unless you made the same mistake I did. Now what we're getting here is a mirror image. It's been flipped on the vertical axis, or rather flipped on the horizontal axis, I should say, but it's flipped as far as up and down goes. So what we need to do is reverse the y coordinates here. And that means that everywhere where the y is 0, it changes to 1, and everywhere where it's 1, it changes to 0, like that. So then whenever we run it, we should get the proper coordinates. Yes, now the image looks like it's supposed to look. That is the basics of drawing an image to the screen. I hope this video wasn't too difficult to follow, and I hope it didn't take too long. Just real quick, I'm going to show you a little fun you can have with the colors of the image. If we go to the event listener, and before graphics.drawImage, we say graphics.setColor. Let's set it to red. Let's see, 1, 0.5F, 0.5F, 1. So this should tint it mostly red. And as you can see, that's what happens. Oh boy, that's scary. It's like Nicolas Cage, a cross between Nicolas Cage and Satan. Anyway, basically, that's the essence of drawing images to the screen in OpenGL. You map them to a quad, and you draw the quad to the screen like you've been doing previously. That's why I wanted to make the fill-rect method first. Like I said, I hope that this video wasn't too difficult to follow. If you have any questions, leave them in the comments, and I will do my best to answer them. Like I said, I have some trouble answering some OpenGL-related questions because there are errors that people get with the Glgl library itself, and like I said, it interfaces with native code on your computer, so sometimes you'll get errors that I won't be able to fix, but I'll do my best to answer the questions that you might have. Thank you so much for watching this video. Like I said, I'll try to upload videos Monday through Friday consistently if possible. I missed an episode yesterday because I was busy, but I'll try to upload every weekday, so subscribe so you don't miss any episodes. Again, thank you very much for wassailing. Thank you very much for wassailing. It is Christmas after all. And I will see you in the next video.